First, let me remind you formula for integration by parts. Definite integral. So when we have integral from a to b of f of t times g of t with g prime, of course, with respect to t, this is equal f of t times g of t, limits from a to b, minus integral from a to b of f prime of t, g of t with respect to t. F and g prime function must be continuous. In our example, we have only inverse sign. So first, we can rewrite our definite integral from 0 to 1/2, and we can put inverse sine of t times 1 dt. So inverse sine is continuous, 1 is continuous function, so everything is okay. Let me put that f of t is equal inverse sine of t. So f prime of t is equal 1 over square root of 1 minus t square. And whatever left is our g prime with respect to g of t is equal 1. So our antiderivative is equal t. So now we have to just plug this to our formula. So we have this is equal f times g. So we have t times inverse sine of t, and we have limits from 0 to 1/2 minus, now we have definite integral from 0 to 1/2 of f prime is equal 1 over square root of 1 minus t square times g is equal t with respect to t. So this is equal. We can copy first expression. So we have t times inverse sine of t, limits from 0 to 1/2. And to solve the second integral, we will use substitution method. Let me rewrite this, that this is first, we can change square root to power form. So we will have, let me copy integral symbol from 0 to 1/2, and we will put that we have 1 minus t squared to power negative 1/2. I change square root to power form times t dt. So this is equal. We have t times inverse sine of t, limits from 0 to 1/2 minus, and now we will use substitution method. So let me put that our 1 minus t square is equal u. So derivative of both sides now have to calculate. So negative 2t is equal du with respect to t. So we have to multiply both sides by dt to reduce denominator, dt and dt, because when we do use substitution we have to find du. So we had that du is equal negative 2t dt. We have in our integrand only t dt. We don't have negative 2. So now I will divide both sides by negative 2. Negative 2 and negative 2 we can reduce, and we will have that dt is equal negative 1/2 du. So we will have integral from 0 to 1/2 of 1 minus t squared is u to power negative 1/2 we have to copy, and for d it should be t, of course dt is equal negative 1/2 we will put in parentheses du. Because I didn't change the limits, I have to come back to the substitution at the end, to t substitution. So this is equal. We have t inverse sine of t, limits from 0 to 1/2, minus, and now we have negative and negative, so we have to change this to positive sign. 1/2 I will take before integral symbol, so we have integral of power function formula used to now. So u to power negative 1/2 we have, so it will be u to power negative 1/2 plus 1 over, the denominator is the same like exponent, and we have limits from 0 to 1/2. So this is equal. We have to copy first expression. And we have plus 1/2. Negative 1/2 plus 1 is 1/2. So we have to flip this fraction, so it will be times 2 over 1, so I can put 2 times 2, and u will be to power 1/2, limits from 0 to 1/2, so this is equal. We have t times inverse sine of t, limits from 0 to 1/2, 2 and 2 we can reduce, and now we have to come back to substitution because I didn't change the limits, so it will be plus 1 plus t square. We have to power 1/2, so this is square root of, and we have limits from 0 to 1/2. So this is equal. Now we have to plug the limits, minus, of course, minus. We have here minus 1 minus t square. Now we have to plug limits, first upper limit instead of this, so we have 1/2 inverse sine of 1/2 minus, now we have to plug 0, so when you multiply 0 times sine, inverse sine, it will be 0, so we don't have to put, and now we have plus, so we have to change the sign, and we have to plug first upper limit, so it will be square root of 1 minus 1/2 to second power minus lower limit, so we have to substitute t by 0 now, so it will be minus square root of 1 minus 0 square, so this is equal. We have 1/2 inverse sine of 1/2 plus we have square root of 1 minus 1 over 4 is 3 over 4 minus we have 1, square root of 1 is 1. So this is equal. We have 1/2 inverse sine of 1/2, and we have square root of 3 over 4, so it will be plus square root of 3 over 2 minus 1. This is equal. We have 1/2 inverse sine of 1/2 is pi over 6, so we have times pi over 6 plus, and we have square root of 3 over 2 minus 1. So this is equal. we will have pi over 12 plus square root of 3 over 2 minus 1. We can factorize 1 over 12. So in parentheses, we will have pi plus 6 square root of 3 minus 12. This is my solution.